Since time immemorial, humankind has been captivated by a single, profound question that has consistently sparked a sense of wonder and fascination. What lies beyond what we know? What exists beyond the familiar bounds of our universe? This question, both ancient and complex, has driven countless inquiries and theories across generations. Today, as our tools of exploration reach unprecedented heights, we find that the answer to this question grows only more complicated and intriguing. However, thanks to recent advancements in astronomical technology, we are closer than ever to uncovering clues that could fundamentally alter our understanding of the cosmos. The James Webb Space Telescope, a marvel of modern engineering, has recently discovered something extraordinary in the far reaches of the universe, a discovery so massive and fascinating that it has the potential to revolutionize our understanding of physics itself. What exactly has the James Webb Telescope found at the very edges of the universe? And why has this discovery ignited such excitement and anticipation among scientists? We invite you to join us as we explore how this powerful telescope has uncovered something of great magnitude at the very limits of our observable universe. If you're interested in staying updated with the latest news and discoveries about our universe and the mysteries it holds, make sure to subscribe to our channel. Don't forget to like this video and turn on the notification bell to receive updates on our cosmic journey. In 1916, Albert Einstein developed his groundbreaking theory of gravity, a theory that completely reshaped the ideas Newton had established centuries before. When Einstein applied his theory to the universe, he arrived at a transformative conclusion. The universe could not remain static, it must either be expanding or contracting. In 1929, the astronomer Edwin Hubble provided observational support for this theory when he observed that distant galaxies appeared to be moving away from us. This movement suggested that the universe was indeed expanding, a result of the Big Bang, which set everything in motion. In this expanding universe, the distances between galaxies increase over time. Einstein's theory can describe both an infinitely expanding universe and a universe that curves back on itself, similar to the surface of a ball in higher dimensions. Some scientists argue that, because the universe was born from the Big Bang approximately 13.82 billion years ago, it must have an edge, a point beyond which we cannot observe. Therefore, we can only see galaxies whose light has had enough time to travel to us within this span of 13.82 billion years. This limitation forms a spatial sphere, centered around Earth, known as the observable universe. Despite this, the true expanse of the universe is much larger. It is estimated to stretch across an incredible 92 billion light-years. The outer limit of our observable universe is known as the cosmic horizon, similar to the horizon one might see at sea. Beyond this horizon, there are thought to be countless other galaxies whose light has yet to reach us, lying beyond the grasp of our current observational capabilities. The James Webb Space Telescope, being 100 times more powerful than the Hubble Space Telescope, can detect faint infrared light from the universe's earliest galaxies. This remarkable telescope can observe not only galaxies but also stars and planets, potentially even providing insight into their habitability. However, we have yet to discover exactly what it will observe as it gazes towards the outermost edge of the universe. The universe, as we understand it, is divided into two realms, the observable and the unobservable. The observable universe includes everything we can detect, primarily through radiation that reaches us as light. The outer limit of this observable realm is defined by the cosmic microwave background radiation, a remnant of the Big Bang produced around 13.8 billion years ago, at a time when the universe was as dense as a thick fog. Although some experts believe that gravitational waves and neutrinos might exist beyond what we can observe, we currently lack the technology to verify this. Cosmologists have suggested that to truly understand the universe, we must recognize that what we can observe is only a small fraction of a much larger reality. Finding galaxies like Abell 2744 Y1, which exists at the outermost edge of our observable universe, can provide valuable insight into this larger reality. Although this galaxy is so far away that its light has taken over 13 billion years to reach us, scientists are able to study it as it was approximately 650 million years after the Big Bang. The Spitzer, Chandra, and Hubble telescopes collaborated to identify this galaxy, using different parts of the electromagnetic spectrum to capture various forms of data. By combining information from these three telescopes, astronomers identified 7 galaxies that are located at distances far greater than any single telescope could have observed independently. Astronomers from the Instituto de Astrofísica de Canarias and the University of La Laguna used the Hubble Space Telescope to locate Abell 2744Y1. By employing the Spitzer telescope's equipment, they calculated its distance and estimated its number of stars. They also used a technique called gravitational lensing, which acts like a magnifying glass, focusing light from distant galaxies by bending it through intervening galaxies that are closer to Earth. Although Abell 2744Y1 is small compared to our Milky Way galaxy, spanning about 2,300 light-years across, its star formation rate is 10 times greater than that of the Milky Way. This galaxy has a redshift value of 8, indicating that the expansion of the universe has stretched its light toward the red end of the spectrum. Before the discovery of Abell 2744Y1, the most distant galaxy known had a redshift of more than 7. But recently, astronomers discovered an even more distant object, a supernova known as DES 16c 2 nanometers, identified through a dark energy survey. Supernovae are among the most massive explosions in the universe, marking the final moments in the life cycle of a star. Understanding how stars function requires observing their explosive deaths. Massive stars consume vast amounts of nuclear material in their cores, which produces tremendous amounts of energy. This energy creates pressure that counteracts the force of gravity, preventing the star from collapsing. When you see a star shining in the night sky, it's due to a delicate balance between two opposing forces. Massive stars are in a constant battle, with gravity pulling them inward while the energy from nuclear reactions pushes outward. However, when these stars run out of fuel, they begin to cool, the pressure decreases, and gravity eventually causes them to collapse, leading to an explosion known as a supernova. This process occurs rapidly, often within seconds. Supernovae can also occur when two stars collide. DES 16c 2 nanometers, discovered in 2016 by a global team of astronomers, is a Type II supernova, meaning it exploded as it reached the end of its life. This cataclysmic explosion is believed to have taken place around 10.5 billion years ago. Due to the ongoing expansion of the universe, this supernova is now far more distant than it would appear to the naked eye. DES 16c 2 nanometer is particularly noteworthy because it was a dark supernova, emitting very little visible light, making it challenging to detect. However, astronomers identified it using telescopes capable of observing infrared light. The research team dedicated 5 years and over 500 nights of observations to locate and study this distant supernova. Despite the challenges, their efforts proved worthwhile, as studying DES 16c 2 nanometer provides crucial insights into the causes of superluminous supernovae and the immense cosmic explosions they produce. Such a powerful event releases an enormous amount of energy, predominantly in the form of neutrinos and photons. This energy generates a shockwave that travels outward, heating the surrounding gas and dust to produce bursts of radiation detectable across various wavelengths, including visible light, radio waves, and X-rays. This explosion also forges heavy elements like iron, gold, and platinum, essential for forming planets and life as we know it. These elements are then dispersed into the surrounding galaxy, enriching the gas and dust and providing raw materials for future stars and planets. A Type II supernova like DES 16c 2 nanometers can profoundly influence the surrounding universe and plays a critical role in the evolution of galaxies over time. By studying the ultraviolet light emitted by superluminous supernovae, SLSN, scientists can calculate the quantity of matter produced and the temperatures reached during these explosions, which is crucial for understanding these events. There are distinctions among types of supernovae. While DES 16c 2 nanometer is a Type II supernova, which occurs when a massive star runs out of fuel and collapses, other stars, such as Betelgeuse, a red supergiant, are expected to eventually become Type IIp supernovae, which are generally less powerful. Now, astronomers continue to search for more distant supernovae, eager to uncover further insights about these cosmic explosions. What do you believe lies beyond the edge of the universe? Share your thoughts in the comments. If you enjoyed this journey through the cosmos, please remember to like this video, subscribe, and turn on the notification bell. Thank you for watching, and we look forward to seeing you soon.